principle, we can use the microextraction techniques for all kinds of samples. That has been shown with the work of Janusz Pawlishin, for example, over the past years. He uses microextraction techniques for more or less any kind of sample. We focus a lot on headspace sampling for volatile or semi-volatile compounds. And here we indeed see that actually you can analyze all kinds of different samples. From solid samples, where we are interested in the desorption of compounds. You could imagine, for example, an application where you are interested in finding out about the typical smell of new cars or something like that. That is something you would do with these devices. But also, of course, and that is basically what we are mostly doing on aqueous systems, aqueous samples, including all kinds of foods, aqueous foods, but also environmental samples. So a very broad range. With the in-tube extraction methods that we are mostly using nowadays, there are a lot of different parameters that one has to optimize, though, or at least one can optimize. And for these, it's important to have, well, some experience, I would say, to focus on the ones that are most important. Otherwise, you can spend quite a long time on method optimization and development. However, based on some such experience, it's also typically easy to focus on just a number of very important parameters that govern finally the sensitivity and robustness of your system. For example, obviously the choice of the sorbent is very important. And here we have really the advantage that we can match the analytes of interest by a sorbent that is specifically well suited for these analytes.